Okay, so in this question we're given a quartic function and we need to show that it does not have any points of inflection. So if we look at the sheet, the method to find points of inflection, we're going to follow this. So we're going to do step one, we're going to differentiate it twice, set it to the 0 and solve it. But then we should find that when we do the change of sign test, we should find that there's no change of sign. This is what we'll be looking for, and therefore the point that we find is not going to be an inflection point. So let us begin by first doing the first derivative. So that we get 4x cubed minus 12x squared plus 12x minus 4. And then we differentiate a second time to give us 12x squared minus 24x plus 12, and we set this to 0 and solve this. So we can divide everything by 12 first of all to get x squared minus 2x plus 1 is 0, and this is factorizable, so it's x minus 1 all squared. So we see there's only one point, so therefore x equals 1 is the only potential inflection point, but we need to show that this is not an inflection point. So we'll begin with the second derivative test. We're going to substitute into the second derivative 1.1 and also 0.9. So these are the two points very close to the 1 but on either side. So if we sub this into the second derivative, which is over here, so 12 times 1.1 squared minus 24 times 1.1 plus 12, and if we use calculator we get 0.12, which happens to be positive, and then we sub 0.9 in, plus 12, and if we work that out with the calculator we find it's also 0.12, so that's also positive. So there's no change of sign, so no change of sign, therefore x equals 1 is not an inflection point. So therefore f of x has no inflection points. So the method here then to show that it did not have any inflection points was to basically search for them using the standard method, and you should find it fails the change of sign test.